I am in need of enclosures and shells of custom sizes. Then it just dawned on me. Why not create a perforated construction tube that could be 3D printed with various couplers? I've included some regularly spaced holes intended to be used with some of the most inexpensive fasteners. Check out what I came up with. I wanted to create a versatile structural member that can be used in many different projects. The primary inspirations were the perforated construction tube and aluminum extrusion. The perforations would provide the holes that a fastener could thread into, and why not have that fastener be a super common one? I have a ton of these PC fan screws that are designed to cut threads into plastics as they're set, and they are super cheap on Amazon. The aluminum extrusion-like cross-section is from the requirement that I set to make these members printable without supports. This allows for minimal post-processing, and pulling out supports of a tube like this would not be a good time. Although, I did end up needing to print them with a thick brim to reduce warping. There are better methods to help minimize the warping by interrupting straight continuous lines. Maybe I'll try out a more complex version in the future. Warping could also be reduced further by having a heated chamber, but I don't have one yet, unfortunately. Just the tube is not enough to be able to build structure from, though. I needed a way to connect the tubes together. The highest priority was to come up with something that could easily be mass printed and have layers in favorable directions for optimal strength. Well, the easy way out is just to print a bunch of brackets that could be printed flat on a print bed. I knew I wanted the thickness of the brackets to be the same as the wall thickness of the construction tube so that the shear strength can be maximized. And I just drew them off my CAD model of my proof of concept. My concept being a simple shoe rack, which may end up looking way too over-engineered. I ended up with a straight bracket that can be placed on each side acting like a coupler, an L bracket and an angle bracket. After printing all the parts out, I was able to look at my CAD model to get everything put together. I started by connecting all the straight pieces. The tubes that I printed still ended up having a warp at the ends of one face, so I ended up using just 3 brackets instead of all 4. Even with the missing bracket, I orientated the faces without brackets so that they were in compression whenever possible. In the 2 primary beams, the bottom face is in tension while the top face is in compression, so the tubes are actually being pushed together in this region, so putting brackets there would have done little. After finishing the straight connections, I attached the L and angle brackets. Now I can spread out the pieces like a drawing to make sure I have all the brackets configured properly, then screw everything together. I'm making sure not to tighten these screws, I just need them to seat into their chamfered holes. Only a very small amount of torque is needed to apply to these screws to handle the expected loads, and stripping out threads is very easy in plastic. Now I know what you're thinking. It is completely obvious that I'm going to use magnetic levitation to keep the shoes on the upper level, so I don't need to mention it. However, you will be sorely mistaken. I actually purchased some inexpensive acrylic, cut out the necessary corner slots to accommodate the brackets in the corner, and hot glued the panels onto the tubes. Now in this case, hot glue can actually be quite strong. I can even lift the whole structure from the center panel. I'm just using a standard Gorilla hot glue, but I'm using it in a glue gun that gets very hot. I have left it too long before and actually heard the glue boiling and burning. Now it may hurt like heck when you get this on your skin, but it starts to act more like a braise when the glue gets this hot. Maybe one day I'll do a video showing off its strength. Now that the acrylic is glued on, the shoe rack is complete. I think it turned out great. The downside of getting the cheapest acrylic you can find is the occasional blemish, but it doesn't really matter. Get subscribed for the next videos involving the construction tubing. I plan on continuing to create different sets and expanding accessories available for download. The awesome thing is anyone can make their own accessories that fit as well. Check out these files and more on printables. I plan on creating some new 3D printer enclosures next, as the first one I made was functional, but not exactly elegant. Talk to you in the next Engineers Weekend.